everyone. This is Kevin with Noble IT. Today I'm gonna make a video about site-to-site VPNs using GRE tunnels, GRE over IPSEC. This is very common practice in creating site-to-site VPNs. So I'm just gonna show you configurations, drop some knowledge along the way, and hopefully you'll be able to create a site-to-site VPN just as I will do here. So this is the topology that we have. If you see here on this list, this is kind of like the HQ site right here, and then on the right side you have site B. So we're going to build a site-to-site VPN from this HQ router here to site B router here. We'll be using Tunnel GRE. So let's get to it. First things first, let's open this this router here, 492. All right, so here we have this HQ router. So there's a couple steps that we have to do first. First, I want to build the interface tunnel and make sure we can establish an OSPF neighborship with the other site. That way we can advertise our networks that we want to encrypt with IPSEC, and then we can start with the crypto ISACAMP configurations. So we'll do a show interface description or brief. We'll configure our interface tunnel 0. We're going to put an IP address of 192.168.200.1, subnet mask of 252. No, shut it. Now, tunnel source has to be the physical interface or the IP address. You can either do interface tunnel source Ethernet 00, which I'll do in this case, and you can see here that's my physical Ethernet 00, or you could do tunnel source, and then you can do the IP address of 40.50.60.1. That would work as well. So we have the tunnel source. We're going to do tunnel destination here. This one is going to be the physical IP address of this site B router over here. So tunnel destination will be 40.50.60.5, which we have here in our topologies, the IP address of that interface. So once you do that tunnel destination, tunnel source, you see the interface tunnel comes up. We're going to do a IPMTU of 1400, IP TCP adjust segment size of 1360. And that should be it for the configuration. We can do show run interface tunnel 0. You see it's a pretty simple configuration. We have interface tunnel 0, IP address from TU, tunnel source destination. That's everything we need to bring this tunnel up. You see tunnel 0 is up. We're going to go ahead and do that on site B. Let's minimize this and bring site B over here. Here we got site B, which is this router here. We're going to configure this tunnel interface. Now, as you see here, I'm going to do 200.2, and the tunnel on IP address on HQ is .1. We're going to use /30 subnet mask. Tunnel source is going to be Ethernet 00. Tunnel destination is going to be that physical IP address of this router. So that's going to be 40.50.60.1. Tunnel should come up. IPMTU of 1400. IP TCP adjust maximum segment size of 1360. And we'll go ahead and check the tunnel. Everything looks good. That tunnel is configured. So now I should be able to ping the other side of the tunnel. 192.168.200.1. All right, I ping that. As you can see here, you can see that that local interface there. Now we're going to establish an OSPF adjacency through that tunnel, right? So we're going to do a router OSPF 4. We're going to do network of 192.168.200.0. Wildcard mask .3 into area 0. And I'll go ahead and bring up the HQ router as well, so that way side by side we can see those come up and down. Router OSPF 4, network 192.168.200.0. We should see an adjacency. That was really fast. Show IP route. Let's check the adjacency. Show IP OSPF neighbor. We're worried about this guy right here. Don't mind the other neighbor. So we have the neighbor, right? Came up pretty quickly. Now, the point of this is so that way we can exchange routing information from this site to this site over OSPF. Now, as of right now, on my HQ router, this HQ local area network is, I believe it is 172.20.10.1. So I have this PC over here that is a part of that, and its IP address is 10.10. So 172. If you do a show IP on the little virtual PC here, you can see my IP address is 10.10, gateway of 20.10.1, which is my router here. So I should be able to ping, or not able to ping, this other site B over here. Okay, so we have this other local area network, 19.10.1, ping 172.19.10.1. It times out, right? So what that's doing is I'm trying to ping from here all the way to this Ethernet 01 interface, and it's not working. That is because I have to make that network participate in OSPF. So on this HQ router, if you can see here on my router OSPF 4, I'm not, I don't have a network statement for it. So let's change that. Router OSPF 4, network of 172.20.10. I believe that's what it was. 172.20.10.1, so 1.0 of 255 wildcard mask. So now that's participating in it, and I'll do the same thing on site B. Show IP. Oh, there's the IP. Router OSPF 4. I'm going to put 19.10.1 to area 0. So now if I do a quick show IP route OSPF, there we have that network from site B. So now I should be able to ping. That's perfect, right? Now we have the base topology of what we have, but this video is about the Site-to-Site VPN and encrypting and protecting that data transfer. Right now, if we look at the topology, it's going through here through our ISP provider, and it is all unencrypted, not protected. That's not what we want. Right? We have to make sure that we protect our traffic from the HQ to site B. Now, how do we do that? We're going to use IPSEC, and we're going to use crypto technologies called IPSEC, and let's go ahead and get that started. First things first, we're going to do crypto. We're going to create a crypto IPSEC policy. We'll name it number 1. Do a quick question mark. You can see you have multiple parameters. Authentication for this policy is going to be pre-shared key. Encryption is going to be AES. Group is going to be Diffie-Hellman group 14. Hash is going to be SHA-256. Now the lifetime by default is 86,400, I believe. So we're just not going to leave that. We'll just leave that there. That takes care of the policy on this router. Now we're going to create the crypto ISACamp key. This is going to be that pre-shared key that has to match on both sides for the IPSEC tunnel to establish. We're going to use a password of Cisco123. Address. This is going to be the peer IP address of site B. So this is going to be the physical interface of Ethernet 00 right here. So 40.50.60.5. 40.50.60.5. That takes care of the pre-shared key. Now this has to match on both sides, so we'll do a mirror configuration in a little bit. Now we're going to do the crypto IPSEC transform set. We're going to name this transform set T-set. Do question mark after that. There's multiple things that you can select here. Now this is what's actually going to be on the IPSEC. What kind of encryption are we going to use? What kind of hashing algorithm are we going to use? All these algorithms that we have to choose. I'm just going to choose, let's see, encapsulation security protocol, ESP, advanced encryption, AES. I'm going to 256, and I'm going to use ESP secure hashing algorithm, HMAC. So that's one whole line there. You hit enter. You get into transform set configuration mode. You see here you have different modes, right? By default it's set to tunnel, but here I'm showing you that you can do a transport. Now tunnel is going to encapsulate the whole datagram, where transport mode is only going to be the payload encapsulation. So we want to do tunnel, and we can exit out of transform set mode. Now we're going to do crypto IPSEC profile. We're going to name this IPSEC profile. Here you do a question mark. There's multiple things to do. We're going to do the set command. We're going to do set transform set, and then the transform set that we named. And that's it. That takes care of the crypto configurations. We're not going to apply it just yet to our tunnel interface because I want to do it together at the same time. So right now we'll do the same configuration on site B. I'll kind of speed this up a little bit. Crypto ISACamp. Oops. Crypto ISACamp policy 1. Now these policies do have to match, so keep that in mind. Encryption, yes. Group 14. Hash SHA-256. Crypto ISACamp key 0 Cisco123. Address 40.50.60. This is going to be the physical IP address of this router, which is 40.50.60.1. We're going to do the crypto IPSEC transform set T-set. We're going to do the same thing that we did on the other one. 256 ESP HMAC mode tunnel. It's there by default. Crypto IPSEC profile, IPSEC profile. We're going to set the transform set. And that takes care of our crypto configuration. Now, we're using tunnel interfaces, correct? Now, all we have to do is apply this. It's called tunnel protection. We're going to apply the protection, IPSEC protection on the tunnel interfaces. So, right now, this is our configuration for For a tunnel interface, we're going to get into tunnel 0. We do tunnel protection, IPSEC profile, IPSEC profile. That's what we named it. You can see here, ISACAMP, crypto ISACAMP is turned on, right? And you can see here, tunnel, the neighborship went from full to down, received packet, not an IPSEC. So we're expecting protocol, that's GRE protocol right there. We're expecting an IPSEC packet, and we're not getting that. So we go to interface tunnel. Now, if we quick show, before we apply it on the other side, if we do show crypto ISACAMP SA, this actually should not be that way. It's probably just bugged out. No tunnel protection IPSEC profile. We'll do that. There we go. But we'll apply the tunnel protection to both sides. Tunnel protection IPSEC profile. Profile. IPSEC. Tunnel protection IPSEC profile. IPSEC profile. So as soon as I apply that configuration, you can see our neighborship came back up. It went down and back up. So show crypto ISACAMP SA. And these are the ones that whenever I tore down the session, stay deleted. So we should see a QM idle active. That's what you want to see, and it shows your destination of 40.50.60.5, that physical IP address of the router, and then the source. So that is good. When you see that, you know it is up. But now, how do we actually ensure that our traffic is getting encrypted? There is a command, show crypto IPSEC SA. This right here shows that our packets are being encapsulated, packets encrypted, decrypted, digested, verified, encapsulated, decapsulated. So if you see these incrementing, that's a very good sign that your traffic is protected. We can clear these. We'll do a clear crypto IPSEC, clear crypto IPSEC SA counters. We'll do that same command again. You see right now we have 1 and 1. Right, so we can verify with this. We log into this virtual PC again. We'll do a ping. So we're sending traffic over the tunnel. So we sent some pings there. Now if we run that same command again, you can see that our traffic went through, encapsulated, encrypted. There we go. Our traffic is incrementing. The traffic is perfected. And just to show a final overview of that configuration, do a show run section crypto. There you can see the bare bones of the configuration. These are the steps to do it. It's fairly simple. You create the policy that you want with the parameters. You create a pre-shared key. You create the transform set for IPSEC, the profile, and apply that transform set. Then you apply it to the tunnel interface with this command, and then you can do some verifications. So there you go. If there's any questions or you feel like commenting on the video, just let me know. Hope this helps someone. See you next time.